Today I'm going to be showing you how to determine the rate law reaction using experimental data. Your rate law equation is rate equals K, which is your rate constant, times the concentration of A to the order A, times B to the order B. In this equation, your A will equal your NO2, and your B will equal your CO. So to determine the rate law of NO2, you're going to look for experiments where NO2 changes and CO stays constant. I chose experiment 1 and 2. You could also choose experiments 3 and 4, but the numbers are a little harder to work with. So to find the rate law of NO2, you're going to look at the change in concentration of NO2. By dividing your second experiment, which is 0.30, dividing it by your first experiment, which is 0.10, and that will give you a factor of 3. So your concentration of NO2 is increasing by a factor of 3. Next, you're going to look at the rate change. You're going to do this by dividing your second experiment, which is 0.0153, by your first experiment, which is 0.0017, which will give you a factor of 9. So the concentration of 3 raised to the power of A from here equals 9. So 3 to what power will give you 9? You could see that 3 to the second power will give you 9. So your rate order is 2. To find the rate law of CO, you're going to look at the same things, but you're going to look at experiments where NO2 stays the same and CO changes. I picked experiments 2 and 3. Again, you're going to look at the change in concentration of CO by dividing your second experiment, which is 0.20, and dividing that by your first experiment, which is 0.10, which will give you a factor of 2. So your concentration of CO is increasing by a factor of 2. Then you're going to look at the change in rate. You're going to do this by dividing your second experiment, which is 0.0153, divided by your first experiment, which is 0.0153, which will give you a factor of 1. So the concentration of CO is increasing by 2 to the B order from up here is equaling to 1. This might look scary, but remember that anything to the exponent of 0 gives you 1. So the rate law is the concentration of CO is increasing by 2 to a factor of 0 is equaling to 1. So your rate law for CO is just 0. Okay. Now we're going to want to put all of that together into the rate law equation, which will give you rate equals K, which is your rate constant, times A, which is your NO2, to the second order, times CO, to the 0th order. And now remember what we said here, where anything to the power of 0 just equals to 1. So we could rewrite this to NO2 to the power of 2 times 1. And since anything times 1 is just itself, you could get rid of the 1 altogether. To find part B, to determine the value of your rate constant K, you could use any of your experimental data. I just use experiment 1 because it has the easiest numbers to work with. You're going to want to solve for K in your rate law equation. You could do this by dividing your rate by your NO2. Now you're just going to want to plug in the data from your experimental chart, which is going to be your rate, which is 0.0017 to its units, molarity over seconds, over the concentration of NO2, which is 0.10 times its units, which is molarity, raised to its order, which is 2, will give you K. Now you're just going to simplify, which is going to give you 0.0017 to its units, M over S, over 0.01 molarity to the second power. To further simplify this, you're just going to do 0.17, and one of the molarities from down here will cancel out with a molarity from up here, giving you a unit of 1 over S times M. Or you could rewrite this as 0.17 times the units of S to the negative 1 power times M to the negative 1 power.